In this video, I'll be covering objectives 1 through 3 from Pre-Calc Honors, as you can see, Unit 7. What is a factorial? This is something that you'll see in this unit. It comes up when we're dealing with sequences in series. N factorial, you can see, is defined to be whatever number that is. And we always start with an integer, a non-negative integer factorial, and you take that integer and you keep multiplying it by one less integer until you get all the way down to 1. It's usually easier just to see a couple examples. So 4 factorial is 4 times 3 times 2 times 1, and we multiply all those together, we get 24. 6 factorial, we just tack on a 6 and a 5 to the 4 factorial, 6 times 5 all the way down to 1, and we get 720. A couple of the kind of maybe not so intuitive, 0 factorial is defined to be 1, and 1 factorial is also 1. And then, so starting with a couple examples to help you understand what we're asking for, we're looking for in Objective 1, which is to write the first several terms of a sequence. That's the objective here. And a sequence is just a list of numbers. It's a list of numbers, and we have this notation here that sometimes can be confusing at first and maybe a little bit overwhelming when you see all this notation, but it's really, once you boil it down, it's really not that bad. The first term of let's do this right above here. So a sequence, if we look at a list of numbers, we can just pick any list of numbers like 1, 4, 7, 10, and so forth. We can just put ... So this would be a sequence of numbers in which you just keep adding 3 to the previous number to get the next number. And when you do that, if you have a sequence like that, then you would call this here an arithmetic sequence. So we have arithmetic sequences, we have geometric sequences, and then we have other kinds that are neither arithmetic nor geometric. Geometric would be you multiply one number by the next, each term by the same number to get to the next term. So geometric, we're going to be talking about that in objectives 4 through 6. But the bottom line is, the notation we use is, we would call this the first term, and sometimes we call it a sub 1, and if that's a sub 1, this would be a sub 2, the second term. This would be a sub 3, and so on. A sub 4, and then a sub 5. Now, we don't have to start with a 1. Sometimes we would call it a sub 0, a sub 1, a sub 2. But as soon as you know what number you're starting at, the next number is the next term. So the next integer up. So you always go up by 1s. So a sequence always increases by like the first term, second term, third term. We wouldn't have the first term, then the third term. It's always first, second, third, fourth, fifth. So things like that. And so you could use another letter as well, like over here we have S sub n. We call it S sub n, and we're given the nth term of this sequence to be n squared plus 1. So all we're asked to do here from numbers, for number 18 and 22, is to write down the first 5 terms. So the first term, so probably easier to do it like this. First term would be, let's call it 1, S sub 1. And when in doubt, always start with 1. If we started at S sub 0, then we would have to be told that we're going to be starting n at 0. So the default starting number is always 1. So keep that in mind. So S sub 1 would be 1 squared. All you have to do is put a 1 in place of n. So 1 squared plus 1, and that 1 squared is 1 plus 1 is 2. And then the second term would have to be S sub 2. And S sub 2 is 2 squared plus 1. So it's not so bad. You just put the next integer in line in place of n, and you get the next term. So we have 2, and then we have 2 squared plus 1, 4 plus 1 is 5. And then we have the next number, S sub 3. Third term would be 3 squared plus 1. 3 squared is 9, plus 1 is 10. And then on and on. 4 squared plus 1, 16 plus 1 is 17. And then S sub 5 is 5 squared. 25 plus 1 is 26. So let's see, write down the first 5 terms. We wrote them down. If you wanted to write them down in a list form with commas, we'd write 2, 5, 10, 17, and 26. So that's the answer. That's writing down the first 5 terms. So S of n equals that for all values of n, but these are the first 5 terms. Let's see.